Hi. So in this video, we're going to learn some new derivatives, and they are the derivatives of exponential and logarithmic functions, okay? So if we have the function log x, and you want to differentiate it, it just becomes 1 over x. And if you've got the derivative e of x, it stays the same. It stays the same as e to the x, okay? Again, these are given in your formula sheet, and again, we need to always think about whether or not we need to use a chain rule, product rule, quotient rule. Okay, so let's look at these. E to the 5x. So we would differentiate that, but we need to think we still need to do the chain rule because that is e to the 5x. We think of that as the function e to the power of the function 5x. So it's a function within a function. So it still uses the chain rule. So the first thing we're going to do is differentiate the outside function, which just gives us e to the 5x because it differentiates to be the same, but then we need to times it by the derivative of what's inside the brackets, which in this case is 5x, and the derivative of 5x is 5, so it's 5e to the 5x. Okay, next question. We have the derivative, we need to find the derivative of log of x to the power 4. There are two different ways of doing this question. We could firstly think that if we remember our log rules, that actually just becomes 4 log x, if you remember your log's laws, which means that f dashed x is just going to be 4 times log x, which is just going to be 4 times the derivative of log x, which is 1 over x. So the derivative is 4 over x. If you had forgotten to do your log's laws, like that, we could have still differentiated it. Using the chain rule. And it should come out with the same answer. So we would differentiate the log and then times it by the derivative of what's inside the brackets. Derivative of x to the power 4 is 4x cubed. And that's going to simplify because 3 of these cancel out. That cancels out, and we're left with 4 over x. Same answer, different method. Okay? So let's do a slightly more complicated. We can see here it's two functions. So we're going to initially use product rule, but you can hopefully see here that that is a chain rule within this function. That's fine. So let's differentiate it. Product rule tells us to differentiate the first and leave the second. Okay, and then add, leave the first, and differentiate the second. E to the anything just stays e to the cos x, but then we need to times it by the derivative of what's inside the brackets, which is cos x. So we get 2x e to the cos x plus x squared e to the cos x times the derivative of cos x, which is negative sine x. So we get x squared e to the cos x negative sine x. So we get 2x e to the cos x minus x squared e to the cos x sine x. And to be neat, let's take out the common factor of x e to the cos x, which is going to leave us with 2 minus x sine x. Okay, last one, we're differentiating log of tan x. So again, we now know that the derivative of log x is just 1 over x. So this goes 1 over tan x times by the derivative of what's inside the brackets. And so then we need to do the derivative of tan x. So we get 1 over tan x times the derivative, and you would go and check your formula sheet if you can't remember it, which is actually on the previous page. For me, derivative of tan x is sec squared x. In place, yep. There we go. So we get sec squared x over tan x. And that's the exponential and logarithmic derivatives.